6.3 Elimination Method. Check for standard form and stack like terms. So it must be in standard form to use the elimination method. This is the method that I am most likely to use in algebra a lot. I like the elimination method. It's quick, it's easy. I see my x's are stacked together, my y's are stacked together, and my constant is stacked together. So it's all stacked in standard form, ax plus by equals c. Now what I'm looking for is I would like to combine these two equations together like it's an addition problem, but 3x plus 1x is 4x. Nothing is going to cancel there. Y minus 2y is negative 1y, and nothing is going to cancel there either. I need one of my variables to cancel. So what I'm going to have to do then, because nothing is canceling, I am going to have to multiply the equation by something to make it cancel. How about we try to cancel our y terms? What could I multiply the first equation by that would make y cancel with a negative 2y? If I had 2y and a negative 2y, then both of them would cancel. I'm going to multiply this equation then by 2, and I'm going to distribute that 3 times. 2 times 3x is 6x. 2 times 2y is a positive 2y. 2 times 2 is 4. And now I have my second equation. I have x. Notice I'm lining up my x's. Minus 2y equals 10. Now I'm going to add this up. My 2y and negative 2y cancel, which is exactly what I wanted. I needed to have one of my variables eliminate. Now I have 6x and a positive 1x, that's 7x, equals 4 and 10 is 14. I have a one-step equation and I solve for x and I get x equals 2. Then I go back and I substitute it into one of the equations. I need to substitute in that x is 2. Let's go with the first equation. We have 3x plus y equals 2. I'm substituting in for x, so that's 3 times 2 plus y equals 2. We found that x equals 2, and we're substituting that in for the x value. Now I have an equation that has just y, and I can solve for y. We have 6 plus y equals 2, and we get that y equals negative 4. Subtracting 6. Our solution then is 2, negative 4, and we can check to make sure this is true. We're going to check 2, negative 4. My first equation is 3x plus y equals 2. 3 times 2 minus 4 for y. And we get 6 minus 4, and 2 equals 2. So that one works. Checking the second equation, x minus 2y equals 10. So x is 2 minus 2 times y, and y is negative 4. We have 2, and then negative 2 times negative 4 is a positive 8. And we get a true solution. Therefore, 2, negative 4 is a solution to the systems of equations. Let's try a couple of examples for 6.3. All right, the first step is to have them both in standard form. The first equation is in standard form, but not the second equation. We need to have our x and y together on the same side. So the first equation is 6x minus 3y equals 36. And for the second equation, we have 5x. And I need to shift my positive 3y over to the left. I'm going to do the opposite of 3y and get a negative 3y equals 30. I'm looking at my variables here. 6 and 5 is 11. Negative 3y and negative 3y is negative 6y. So nothing's going to cancel. What could I do? Should I eliminate the x or the y? I noticed that if I just had a positive 3y, it would cancel with a negative 3y. Why don't we multiply the equation by negative 1? And that'll change the sign of negative 3y to a positive 3y. We have negative 1 times 6x. Negative 1 times negative 3y is a positive 3y. And negative 1 times 36 is negative 36. And then we still have 5x minus 3y equals 30. Now my y terms are going to cancel. Positive 3y and a negative 3y equals 0. Negative 6x and a positive 5x is negative x equals negative 36. Positive 30 is negative 6. We still do not have x by itself. It's being multiplied by a negative, and there is a 1 that's understood to be there. So if it's being multiplied by negative 1, I can divide by negative 1. Negative divided by a negative makes it positive. And my negative 6 divided by a negative 1 becomes a positive 6. We're going to substitute in our x. Let's use the first equation, 6x minus 3y equals 36. Substituting in for x, that's 6 times 6 minus 3y equals 36. We have 36 minus 3y equals 36. When I subtract 36, I get negative 3y equals 36 minus 36 is 0. And when I divide by negative 3, I get y equals 0. The solution then would be 6, 0. If you're unsure of whether or not 0 is really a solution, you should check your answer. One more example. A farmhouse shelters 11 animals. Some are cows, some are ducks. Altogether, there are 34 legs. How many of each animal are there? A farmhouse shelters 11 animals. Some are cows, some are ducks. We could say that cows plus ducks equals 11 animals. Altogether, there are 34 legs. Cows have 4 legs, and ducks have 2 legs. And there are 34 altogether. We're going to use the elimination method. I would like my d terms to cancel. What do I need to multiply the first equation by so that my d's will cancel? We're going to multiply by negative 2. Negative 2 times c, negative 2 times d, and negative 2 times 11 is negative 22. Here we see that negative 2d and positive 2d are going to cancel, and we're left with 4c minus 2c and 34 minus 22. We get that cows equals 6. So we have 6 cows plus D equals 11, and we see that the ducks equal 5. Six cows, 5 ducks. Just check your solution. Cows have 4 legs, so that's 24, plus ducks have 2 legs, so that's 24 plus 10, which is 34. And that is it for Chapter 6. I just wanted to go over systems of equations. Next, we're moving on to exponents.